dear children. In the previous video, we were discussed exercise questions. So this topic is very big topic actually. It is. I think it takes 12 to 13 videos to complete this lesson. Very big topic, dear children. It is. So now the next concept of this topic, number systems, is representation of irrational numbers on the number line. Very interesting. Before going to represent irrational numbers on the number line, here we use one concept that is related to right angled triangle. That concept is related to right angled triangle. So, dear children, recall your earlier knowledge. What is right angled triangle? So, in a triangle, if any one angle measures 90 degree, then that triangle is called right angled triangle. So, consider the triangle ABC. In this triangle, angle B is 90. So, this is right angled triangle. So, there are three sides in this right angled triangle. The side opposite to this right angle, this side AC, is called hypotenuse. What it is called? Hypotenuse. And a famous mathematician found a relationship between the three sides of a right angled triangle. The name of that famous mathematician was Pythagoras. Pythagoras. That is why this statement is regarded as Pythagoras theorem. So the great mathematician Pythagoras invented, discovered, found a relationship between three sides of a right angled triangle. That statement is, in a right angled triangle, square of hypotenuse, yes, that is AC square, square of hypotenuse, this is equals to sum of squares of other two sides, means AB square plus BC square. Like this, the three sides of a right triangle are related. So this concept was introduced by a great mathematician Pythagoras. That is why this statement is called Pythagoras theorem. Yes, what is said about right triangle, three sides of this triangle? In any right triangle, square of the hypotenuse, if you square that hypotenuse, that is equals to sum of the squares of the other two sides. Square the side AB, square the side BC, find their sum. That sum is equal to square of this one side, that is hypotenuse. So means through this, can you tell me in right triangle which side is greater? Yes, obviously it is hypotenuse is greater in right angled triangle. So square of hypotenuse is equal to sum of squares of other two sides. Now consider the right triangle is like this. Say this is PQR. Here PQR is a right angled triangle. Just tell me then which is hypotenuse? The side which is opposite to right angle. Yes, this is the right angle. Its opposite side, that is PR. This is called hypotenuse. Okay. So then apply Pythagoras statement What is it about the three sides of this right triangle? Square of hypotenuse, that is PR square. PR square is equal to sum of the squares of the other two sides. Other two sides square and sum. PQ square plus QR square. Clear? So this is about Pythagoras theorem. This theorem is holds good for only right angled triangle, not other triangles. Okay? So we use this concept to represent irrational numbers on the number line. First, we locate root 2 on the number line. Number line. Yes, locate or represent root 2 on the number line. Okay, we'll see how root 2 can be represented on the number line. At first, draw a number line with the help of scale. Okay, this is a number line. Take this as 0. Take 1 centimeter. These dimensions are not accurate. Okay, so this is 1, 2, 3, and here it is -1, -2, -3. We represent root 2 on the number line. So the Greeks, they discovered the representation of root 2 on the number line at first. How they located root 2 on the number line? We follow their method only. So according to them, first take OA as 1 unit. Say this is 1 unit or 1 centimeter. Draw perpendicular to, say this point is A. Say this is A. OA is how much? OA is 1 unit or 1 centimeter. Okay. So at A, draw a perpendicular line of length 1 centimeter. That is at O, at A, draw a perpendicular from A such that that is also 1 centimeter. So now say this point is B. Clearly, say this is A. Say this is A. AB is how much? 1 centimeter or 1 unit. This is also 1 unit. Then join OB. Join OB. Now a triangle is formed OAB. Yes or no? Here I drawn perpendicular from A. So here angle is 90 degree. So then which type of triangle it is? Right angle triangle, because here perpendicular is there. OB is perpendicular to this. So this is right angle triangle. Then what is the length of OB? Yes, apply Pythagoras concept. So in triangle, which type of triangle it is? Right angle triangle. In a right angle triangle, OAB, apply Pythagoras theorem. OB square is equal to BA square plus AO square. So BA square, BA is how much? 1 unit. 1 is square plus AO, how much it is? 1. That is also 1 square. Then 1 square is 1 plus 1 square is 1. 1 plus 1, 2. OB square is 2. We want OB. not OB square. So shift this square to right side, that becomes root 2 square to other side. So the length of OB is root 2. Okay, but I have to, this is what is the length of this root 2. Okay, so I have to represent this length on the number line. How? Use compass. Take a compass. This is the tip of the compass with O as a center, means keep the tip of the compass on O, with OB as radius. OB as radius. Adjust the tip of the pencil on B. Draw a semi-arc such that intersects the number line. Okay, dear children, this length is same as this length. This length, yes, no? This length is same as this length, no? This is how much? Root 2. Then this is how much? This is also root 2. So here to here represents root 2 on the number line. Clear? So dear children, OB is same as this point. Say this point is P. Say this point is P. Yes, P represents root 2 on the number line. Clear? That root 2, this is OB, what is its length? Root 2. OB is same as OB. So this is also root 2. This point represents root 2 on the number line, and root 2 lies between the rational numbers 1 and 2. So we conclude that 1 and 2 are rational numbers. Between any two rational numbers, there exists a irrational number. Not only this root 2, between any two rational numbers, there are infinitely irrational numbers are also we can find. Yes, in this way we locate root 2 on the number line. Clear? So what we did, first we draw a number line. Say take the center point as 0, 1, 2, 3, so on, minus 1, minus 2, minus 3, so on. Okay? So to represent root 2 on the number line, take OA as 1 centimeter or 1 unit. At A, draw a perpendicular of length 1 unit. Then join OB. So to find OB, the length of OB, this forms right angle triangle. Apply Pythagoras theorem. You can find the length of OB. Then take compass. Take O as center, OB as radius. Draw an arc such that it intersects the number line. So this length is the one. This is same as this length. So what is its length? This is root 2. Here to here also this is the length of root 2. So this point represents root 2 on the number line. It lies between 1 and 2. Its value is more than 1 and less than 2. Clear? Okay. So dear children, pause the video. Now write this rough and later with the help of instrument construct it. Okay? Okay, dear children, now take another irrational number, root 3. How do we represent root 3 on the number line, or locate root 3 on the number line? So first draw a number line. Draw a number line. Yes. Take this as center O. This is 1, this is 2, this is 3, minus 1, minus 2,
we represent root 3 on the number line. Root 3 is what? Irrational number. Yes. On the number line there are irrational numbers also exist. That is why this is called real number line. So to represent root 3 on the number line, first keep in your mind that what is this? Before irrational number, its preceding irrational number, root 2. So to represent root 3 on the number line, first you should represent root 2 on the number line, then you are able to, then you can locate root 3 on the number line. See here. Oh, now first we represent root 2 and first we represent root 2. So recall that procedure. Take 1 centimeter. This point as A. OA is how much? 1 centimeter. At A, draw 1 centimeter perpendicular line from A with the help of scale. Okay, this is 1 centimeter. Say this is B, then join in OB. So clearly OAB is right triangle. Which type of triangle it is? Right angle triangle OAB, because angle A is 90 degree. So by Pythagoras theorem, what is the length of OB? Yes, apply. OB square equals to BA square plus AO square. AO square, 1 square plus 1 square. 1 square is 1 plus 1 square is 1. 1 plus 1, 2. OB square is 2. OB equals root 2. So what is its length? Root 2. Next, represent it. Take a scale, compass, take OA as center, OB as radius, draw an arc. Yes, this length is same as this length. This is root 2 means this length is also root 2. Take this point as P. Now P represents root 2 on the number line. More than 1, less than 2. But the question is, locate root 3 on the number line. To locate root 3 on the number line, we use this concept. First we located root 2 on the number line. Then we can locate root 3 on the number line. Again, this is root 2 now. Take this as base. This as a base. Draw perpendicular 1 centimeter line from B. That is like this. This is vertex of the protector, vertex of the angle. They should coincide. Baseline should coincide. This is the proper position of the protector. At B we draw 1 centimeter line such that is perpendicular, means 90 degree. Go through the baseline, there is 180 degree, don't count from that. Go through the 0, 30, 40, 50, 60, 70, 80, 90. Here is 90. Mark over there. Yes, this is 90. Again, take a scale, draw a line of length 1 centimeter. This should be of 1 centimeter. If you extend it, it should pass through that point, 90 degree marker point. So draw 1 centimeter. Assume that this is how much? 1 centimeter. Say this is C. Okay. Now this is root 2. Again, join here. What is the angle here? 90 degree now. What is the angle here? 90, because we made this line perpendicular to this line. So here it is 90 degree. Then join OC. Yes, consider the triangle OBC. In triangle OBC, this is perpendicular to this, means here angle is 90 degree now. So this angle is 90. So means which type of triangle it is? Right angle triangle. Angle C, angle B is equal to 90 degree in this triangle. In this triangle. So apply Pythagoras theorem. This is right angle triangle, means here it is 90. This is OC is hypotenuse. OC is what? Hypotenuse. So by Pythagoras, OC square is equal to CB square plus OB square. CB square plus OB square. So CB square, CB is how much? 1 its square. OB square, OB is how much? Root 2 its square. Okay. So 1 square is 1. Root 2 its square. Observe. Root 2 its square. Root 2 its square is this, we can write root 2 into root 2. Root 2 into root 2 is root 4. Square root of 4 is 2. So then what is the value of root 2 into square? 2. So right here 2. 1 plus 2, 3. OC square is 3. Then OC is equal to what? Root 3. Shift this square to other side. Then what is the length of OC? Root 3. Again, take a compass. Take compass. With the help of compass, with O as a center, OC as radius, draw an arm that should intersect the number line. So this length is equal to this length. So OC is same as O and this point. Okay, clear? This point shows root 3 on the number line. Okay, what is the name of this point? Say this point is Q. Q represents root 3 on the number line. Its length is root 3. This is same as this length. Both are same length. OC is same as OQ. So Q represents root 3 on the number line. Its value is also greater than 1, less than 2. Between any two rational numbers, there are irrational numbers are also there. Okay? Yes. In the exercise 2.2, in exercise 2.2, there is a question that is, 1 minute dear children, I will see the textbook. Okay dear children, in your exercise 1.2, the third question is, show how root 5 can be represented on the number line. So we will do the same process. Yes. First you should show root 2 on the number line. Yes. Then after that root 3. After that root 4. Root 4 is not irrational number because it has a perfect value, exact value. This we can write in the form of P by Q. But to represent root 5, first we should show root 4 on the number line, then we can represent root 5 on the number line. Yes, now we follow the same process. Now we are going to represent first root 4 on the number line. Root 4 is nothing but 2, that is 2 here exactly. Yes or no? Then root 5 on the number line. Okay, there are two methods. Now in the same manner, take another method. On the root, this is root 3 now. This is the point C. Again, from C draw one more line, 1 centimeter such that is perpendicular to OC. Use protractor. Vertex of the protractor and vertex of the angle should coincide. Baseline should coincide. Yes. Count. Go through the baseline. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Here it is 90. Yes. Here it is 90. Then take a scale. Draw 1 centimeter line from C 1 centimeter line from C such that if you extend it, that should pass us through this 90-degree marked angle. Assume that this is 1 centimeter. So how much it is, dear children? 1 centimeter. Say this is the point B. Then join OD. Again, here it is 90 degree. This type of triangle is for right angled triangle. So in right angle triangle, which is that OCD. Angle C is 90, means this is what? Hypotenuse. Apply Pythagoras. By Pythagoras, OD square is equal to OC square plus DC square. Or first we can write DC square plus OC square. No problem. Yes. So OC square. OC is how much? OC root 3. That is root 3. Make it square. DC, that is 1. Its square. Root 3 square is root 3 its square. Write root 3 2 times. Root 3 into root 3, root 9. Square root of 9 is 3. So what is the value of root 3 its square? 3 plus 1 square is 1. 3 plus 1, 4. OD square is 4. Then OD is what? Root 4. So what is the length of OD? Root 4. Again, this is root 4. Take compass. And take a compass with O as the center, OD as the radius. Draw an arc. Okay. So, dear children, OD is same as this length. This is root 2. This is also root 2. Okay. So then root 2 not root 4. This is root 4. This is also root 4. So this point represents root 4 on the number line. Now give a name to this. Say this is the point. Actually, this on this number line, I am not did actually. Just it is geometrical error. Actually 2 is here, and this 3. These are not by exact scale. This is root 4. This is also root 4. Root 4 value is 2. That should coincide on 2. Say this point is R. So R represents root 4 on the number line. Done. Now we can represent root 5 on the number line with the same procedure. So what is that procedure? Yes, tell me. Take a compass for a protractor. From D, draw a line perpendicular to OD with the help of protractor. Its length should be 1 centimeter. This is baseline. 0, 80, 90. Here it is. Yes. From D, draw 1 centimeter line segment. Draw 1 centimeter line segment from D. If you extend it, that passes through this marked angle. Yes. Say this is E. It is 1 centimeter. Then join OE. Okay. Here what is the angle? 90 degree. Because this is perpendicular to this. So again, which type of triangle is formed? Right angled triangle. So in right triangle, which is that? ODE. Yes, by Pythagoras. Yes, this is 90 degree means this is what? Hypotenuse. Apply Pythagoras theorem. OE square of hypotenuse. OE square is equal to ED square plus DO square. So ED square. ED is how much? 1 centimeter. Plus DO is how much? That is root 4. This is root 4 whole square. 1 square is 1, root 4 x square is do the same. You will get 4. 1 plus 4 is 5. OE square is 5. OE is root 5. So what is its length? Root 5. Again, with the help of compass, take a compass. With the help of with this O as a center, OE as radius, draw one more arc. Yes, here it intersects on the number line. So dear children, this length is same as this length. Both are of same length. Okay. Then this is root 5. This is also root 5. So this point is root 5 on the number line. Say this point is, this is our earlier point. This is R. This point is say S. So S represents root 5 on the number line. In this way, we can represent irrational numbers on the number line. Dear children, here mine construction is not accurate. That is not according to the scale. Yes, I am doing randomly. While you constructing or locating root 5, root 2, root 3 on the number line, you should do the proper scale. Clear? So we use this concept, Pythagoras theorem, to represent irrational numbers on the number line. Okay? So in the next video, we are going to learn new concept, another concept, that is decimal expansion of a rational number and irrational numbers, rational numbers and irrational numbers, and their decimal expansion. Clear? So pause the video, write the procedure for the construction. If you have any doubts, call me and I will give